in this question, we have to find out the rate at which thermal energy is transferred from the liquid. Okay, so it means that heat is taken out of the liquid which has a mass m stated here, and its specific heat capacity is C, and it cools. So when it cools, that it means that maybe you can consider the process of refrigeration, in which also the heat is taken out of the things which is inside the refrigerator. So in this scenario, what will happen, the temperature will drop. So if certainly if the liquid has a certain temperature in the beginning, right? So that is a temperature at some point. Okay, and this is a, by the way, temperature axis, and this is the time axis. So this is the temperature time graph. So this is how the temperature will decrease uniformly. Okay, why? Because in this question you have to find out the rate at which thermal energy is transferred. So we are taking out the heat at a uniform rate. That's why the graph is like this. Okay, now the power is, we know, is the rate at which work is done. Okay, and this work, for the thermal physics, we know that this work is equals to the change in thermal energy, right? It can be the gain in thermal energy, or it can be the thermal energy that you are taking out of the system. So in both of these scenarios, this work done is equals to change in thermal energy. According to the work energy principle, you know that by we can say that it is the change in thermal energy, okay, which is obviously a thermal energy lost divided by the time taken. So if we put the values, I mean the equations, so that should be delta Q over delta T. Okay, now what is the equation of the heat thermal energy? That is mc delta T over time. So can we bring these two things in one bracket? Because this is giving us the gradient of this graph, which I had already shown. So we can say that the power is equals to mc into the slope or the gradient of the graph. And in this question, they say that the rate of change of temperature of liquid is K. Okay, which means that if you find the slope of this graph, if you find the slope or gradient of this graph, that is a number K. Okay, so we can say that the power is equals to now mck. So that's what they were asking, the rate at which thermal energy is transferred. So it doesn't mean that you have to find out the Q. It means that you have to find rate. Rate means that how fast or slow you are taking heat out of the system, which is obviously the power. So our answer is, dear students, option D. I hope you understand.